Hey, this is Dr. B, and let's go over question number 42. It says water is added to 4.267 grams of uranium hexafluoride. The only products are something that has UFNO in it. Let's call it UFO. And they call it a solid. And also, the rest of it is a gas, 0.970 grams of a gas. That gas happens to be 95% fluorine, and the remainder is hydrogen. I have to admit that that's a perfect match for HF, which is a very common substance. Hydrogen worth 1, fluorine worth 19. That's 5% hydrogen, 95% fluorine. You could calculate it out, but to save time, let's just assume that gas is HF. So what do we know? We know that water reacted with UF6 to make UFO and a gas, which is HF. We have the amounts of 3, which means we can figure out the amount of water that was formed. I'm not sure we need it, but I couldn't resist. Okay, question A. From these data, determine the empirical formula of the gas. We did that right away, HF. If you want to see it in more detail, I'll show you a much cleaner typed key that I found on the web. Okay, so it's 95%, it's HF, so that's the answer to A, bingo. B, what fraction of the fluorine in the original compound is in the solid, and what fraction is in the gas after the reaction? Well, that should be doable. Maybe the quickest way to do it is, well, we need to figure out how much fluorine's in the original compound. So if you have UF6, it looks like it's roughly 1/3 fluorine and the rest is uranium. In other words, UF6 has a molar mass of 352 grams, of which 6 times 19, or 114 grams, came from the fluorine. That comes out to be 1.382 grams of F that are in UF6. Now let's figure out how much are in the gas. Well, the gas is 95% fluorine, so we just do 0.95 times the 0.970 grams. So you have 9.9215 grams of fluorine in the gas. You started with a total of 1.382 grams fluorine, so the rest must be in the UFO. So we subtract it out and we find there's 0.4605 grams of F in the UFO. Now we didn't have to do that already because we could right away figure out that if there's 0.9215 grams F and your total is 1.382, well, 2/3 of it is in the gas and 1/3 of it is in the UFO solid. I think we're going to need this number later anyhow, so I'm glad we did it. So that's what it is. 2/3 in the gas, 1/3 in the solid, with better precise numbers shown here. Part C. What's the formula of that solid product? Well, we know it's UFO, but we don't know what numbers X, Y, and Z are. But we do have a lot of masses, right? You can figure out, there's the F that we figured out, 0.4605 grams. We know from back here that we started with, where is it? The uranium. Somewhere I figured out how many grams of uranium you have, right? There it is, 2.885 grams of uranium, because we did F, and it's just UF6. So if we have the grams of fluorine, which we did from the previous question, the rest is uranium, and that's all you started with total. So that must also be the amount of uranium in UFO. I'll say that again. We figured out how many grams of uranium you started with flat out. It can't go anywhere else, so it's all in the UFO. So we have 2 of the 3. We have 2.885 grams uranium in UFO. We have 0.4605 grams of fluorine in UFO, and it's a total of 3.730 grams. So once again, the rest must be oxygen. So we'll subtract it out, and we get 0.3845 grams. Now we have the entire composition by mass of UFO, so it becomes an empirical formula question. Turn those grams into moles, which I did. I like to put them down there to remind me that that's the empirical formula. It's just not whole numbers. This number is close enough to this number that they're the same. We divide by the smallest number in order to convert these things into whole numbers and multiples, right? And this will become 1, this will become 1, and when you divide that out, it becomes a half. We now scale, double everything, and it's UF2O2. If you're seeing this black thing on top of it, you're not going to see the balanced chemical equation, but it must be. Can I move this thing? Can I exit this thing? Well, this will work. There it is. The balanced chemical equation is UF6 plus H2O makes UF2O2 plus HF. And when you get the numbers in front, meaning actually balance, it's 1 to 2 to 1 to 4. And that is part D, the balanced chemical equation. After I completed this, I was like, I better check to make sure I'm right before I post this to my students. So I looked it up on the web and I got this, which is somebody went to a lot of trouble to make it absolutely beautiful. Meaning that if you didn't understand what I was saying, here's another professor's interpretation, and it's all so clean compared to mine. So use this if it helps. And that is the solution to question 42.